Hi everyone. In the previous video, we had created a basic blueprint script for moving a cube in Unreal Engine 5. That is generally the simplest task that we can have for any kind of dynamic computation that takes place with Unreal Engine. So we're going to add a little bit of complexity to that and create something that is quite common in games, which is a moving platform. So I'm just going to create a new project. So I'm going to click on games over here and I'm going to create a new blank project. I'll select blueprint as the default and I'm going to call it my project 3. So it's going to open the Unreal editor for that. So to represent a platform, I am going to use a plane. So we have a already existing mesh. We have a plane over here. So the movement that we are looking for is the back and forth movement. It is quite common in games. In games like Mario, it is quite common. So the first thing we're going to do is we're going to set this plane as movable. Otherwise, any calculation that is done for movement will not be registered. Similar to the previous video, we are going to add a blueprint script for doing any kind of calculation associated with this actor. So we're going to add it as a component over here in the details tab. So I'm going to click on the add button and add a blueprint script component. So we do know from the previous video that the scene component, if that is selected as the parent for the blueprint, attaching it becomes quite easy. If we select other component types, attachment to another actor can be quite difficult. So we're going to just select the scene component as the parent for the blueprint. So I'll just give it a very simple name, move platform, and it has created a new blueprint and it has opened the blueprint editor for me. I'm just going to add the tab to the other tabs. Okay, so there are two event nodes that have been set up over here for me. What is important with events is in a game engine is we need to know when the event is called and how many times it is called. So any kind of programming that happens for a game engine happens with the tick event or the update event, since this event is called every frame. And since it is occurring every frame and video games generally would run at 60 frames per second, the appearance of changes happens quite smoothly. So from the previous video, we already know that for any kind of movement, we need to change the transform of a given actor. So we can add a world transform. And the target is the actor on which this addition of the world transform takes place. So since this computation is coming from a blueprint, which is a component of the plane actor, we need to look for the parent of the given component. So we're going to get the parent that is attached to this scene component. Okay. So now we need to figure out how much to change the transform of the parent. So for that, we can use the make transform node. And a transform is just a collection of vectors, as we have seen over here. A vector is a collection of a bunch of numbers. So a transform specifically contains the vectors for location, rotation, and scale of a given actor. So in the previous video, we saw that we can just explicitly add a specific number over here, and that will get added to the existing transform, and it will make the actor move. But today we want the platform to move back and forth. So we are going to add the transform twice, and in each case we will add a different value. So I'll just duplicate this network. And so now I have to select when to add this transform and when to add this transform. And for that, since the computation of the transform addition is happening in two directions, we will use the branch node, which will manage that execution flow. So in the branch node, it's going to check a condition. If the output of the condition is true, it's going to make the execution occur in one direction. If it is false, it's going to make the execution occur in the other direction. So now we need to keep track of how much the transform addition has happened. So we can keep track by measuring the distance that the platform has moved, or by measuring for how long in seconds the platform has been moving in one direction. But in this case, I'm going to count the number of frames, since that is the most convenient. So since I do know that the event tick occurs once every frame, I can just keep an integer value and have it be incremented if it's moving in one direction, keep another integer value and have it be incremented if it is moving in another direction. So the check that I'm going to do over here is for movement in direction 1. So first I'm going to create a variable over here. I'm going to call it direction 1 frames. And I'm going to, for this data, it is going to be of the integer type. The moment we drag an integer variable into the blueprint editor, we can either retrieve the value of the variable or we can set a new value for that variable. So we're going to retrieve the value. Then we are going to do a check whether it's, say, greater than or equal to 100. So the greater than value is written over here and the output will be true or false. So that condition is connected to the condition in the branch node. So if it is greater than or equal to 100, I want it to move in the other direction. So I'm going to drag the execution flow and have another branch. So that branch will check some other condition. So I'm going to create another counter, which is going to count the movement or the number of frames that have occurred as it is moving in another direction. So I'm going to retrieve that integer variable, do another check, and then the result of the check will go inside the branch node. So in both cases, if 100 frames have not elapsed as it is moving in a specific direction, which would be the false output, I want it to add a transform, and then I want it to increment the number of frames, the counter for the number of frames. So I'm going to retrieve the direction 1 frames variable and I'm going to just increment it by 1. And that execution will occur after the transform has been added. Similarly, I'm going to do that for the direction 2 as well. And that execution will occur after the respective transform has been added. And this transform will be added only if 100 frames have not elapsed, which means that it will be the false output of this branch. So now if 100 frames have elapsed moving in one direction and 100 frames have elapsed moving in the other direction, then what I want to do is I want to just reset the two variables. So this time I'm going to use the set node and I'm going to reset it, meaning I'm going to set the value to 0. And the execution will occur if the result of the second branch node is true. Then after that, I will reset the direction 2 frame counter. And then after that, I will go back to the first condition check. So that way, if it has moved for 100 frames in direction 2, it's going to reset the two counters and then it will again start moving in direction 1. And this execution will occur every frame. Blueprint, I can compile it, and then we can check if the movement is happening correctly. So now one of the key aspects of these two movements is the location, that is location vector that is being added to the already existing location vector in the transform of the actor. So in this case, I'm going to move in the by positive 1 in the y direction, or by negative 1 in the y direction. I'm going to save, compile, then I'll go back. I'll make sure that the platform is movable. Okay, so now to check whether this blueprint is working correctly or not, I will check if the blueprint is attached correctly to the plane actor, and I will play this in the simulate mode. So I'll just so that my view in the viewport is not reset. So I'll just click on play. We can see the platform moving in one direction, then in the other direction. So that's how you control the back and forth movement of the platform. And one big learning over here is the use of the branch node, and we can replicate the notion of if else if statements using these nodes. So that's what's happening over here. And so yeah, so that's how you implement a moving platform with Unreal Engine 5. Hi everyone, just a small correction. Previously, I had set the execution from the second variable being reset back into the first branch node. I don't think that is necessary, since the first branch node is getting activated every time the event tick is happening. So I don't think this connection is necessary. And so even removing this will be fine as far as implementing this blueprint is concerned. Just wanted to mention this. We can test this out really quickly, and the platform does move back and forth. So just wanted to mention that correction. Thank you.